Am I on?
Yeah.
Oh, okay. Hi, Professor. I'm back because I was just thinking of this problem, and I'm not quite sure. When I was like talking about why before I said that it was a contradiction, I'm not positive if it was really a strong enough argument, but I definitely came up with one that was a bit better. So looking at what we have here, again, just to do a really quick refresher, we were saying that, that this term right here is x plus y, and this term, I think we labeled as m, and this one as p. So this term is going to be p plus x plus y, and this one is m plus x plus y. And so this term together, this term is when you multiply p plus x plus y and the term m plus x plus y together, you're going to get this. And we said that because this divides this term and m plus x plus y divides this term, we know that the absolute value of p plus the quantity x plus y must be less than or equal to x plus y, and likewise the same thing for the other half. However, I stated in the first video that we're also assuming that p and m are not equal to 0 because we want these to be integers, non-zero integers, whole numbers. So that being said, we actually don't need this equal sign. We just want this term to be less than x plus y and this term to be less than x plus y. Well, the only reason that that's going to work out is if this p right here is negative. And same thing with this m must be a negative term. So going back up here to our little puzzle, I'm just going to write in the negative signs there. And this is also under the assumption that x plus y is positive. So I'm just going to prove this, well, rather contradict this, assuming that x plus y is positive and p and m are negative. But I think it would be pretty much the same thing if the signs were switched. Basically, we need p to have the opposite sign as x plus y and m to have the opposite sign of x plus y so that the absolute value of these terms are less than x plus y. I hope you're following and this isn't too confusing. But, so anyways, going back up here then, if we have a positive term times a negative term, that means that this y is going to be a negative. And likewise, we have the same thing over here, a negative term times a positive term, so this x is going to be negative. But that right there is a contradiction because we have a negative term plus a negative term, and that's going to give us a negative term. But we have already assumed that this is positive. So it definitely wouldn't work out, and I tried a few other ways too, starting with this term and trying to manipulate this puzzle so that it works out, starting with the center term. But I haven't found a solution that works, and I don't think it will ever work because of this. So, alright, I hope that made a little bit more sense.